DevOps is one of the most trending sectors in software engineering market, and many of the companies are preferring developers with knowledge about DevOps technologies like Docker, Kubernetes, etc. And believe me, many of you might know about Docker and Kubernetes, but many of you might not actually understand it. And that's the purpose of this video. I will try to make you understand it, why it's needed in the whole software development process. And believe me, in this video, you will know from the development side why it is needed, why there was need for Docker and Kubernetes, and why Docker and Kubernetes, right? So, so before talking about Docker and Kubernetes, I want you to understand about system architecture. And basically, there are three type of system architecture. The first one is monolith, the second one is multi-tier, and the third one is microservices. And that's the main one for this video, not always. And I will tell you why. So basically, microservices is very important, right? But it might not be the best choice all the time. Believe me when I say this, because it might overcomplicate things for you if you don't need it. So let's assume that you have a software development company and a traveling website owner comes to you and says that I need a website for my traveling company. Around 10,000 users are the approximate user base for my website, right? And you make him microservices. That's not the best choice because it might overcomplicate things. It might increase time for your development process. So it's not the best choice always. But when we talk about scalability, if you want to develop software for billions of people, you must know about microservices. So it's important to understand when something is needed and when not. So that's the use case first of all. And why I told microservices is important for this video is because that's the case when Docker and Kubernetes will come into play. So first let me tell you about monolith architecture. I won't take much time. I will try to explain in the most layman terms, right? So basically, let's assume that you have a backend and a server. Let's assume that you make a website with backend and frontend, and you host both backend and frontend on the same server with the same domain. That's a monolith architecture. So same domain for frontend and backend, right? But in multi-tier architecture, you have backend and frontend hosted separately with separate domains. Let me give you a best example of this as well. So I assume that many of you might be familiar with Munstack, right? So Munstack is one of the best example of multi-tier architecture, where you have your backend and front end hosted differently. And in the monolith, one of the best example is MVC in Django and Next.js, which is one of the most powerful tools. But you can also use Next.js for your full stack framework. It's the full stack framework. Next.js is the full stack framework. Many people don't prefer to use the full stack capabilities of Next.js because of scalability issues. They fear of having backend and front end in the same in the code base. So yeah, that's about choices and use cases. But yes, Next.js Django MVC is one of the best example of monolith approach. Monstack is one of the best examples of multi-tier approach when you have your client and backend hosted differently. Now let's talk about microservices because that's the most exciting part for this video, and that's the thing where Docker and Kubernetes will come into play. So let's assume that you have a multi-tier approach. So basically, monolith approach was good, but many people feared of scalability issues, so they shifted to multi-tier approach. So what was the reason we shifted to microservices? Okay, so let me give you an example that you have an API of slash get slash posts. So this makes get request for your posts in the database. So let's assume that you are Instagram SD. So you are the chief product officer of Instagram, and this is a problem that you face. You have your architecture in multi-tier, and when someone makes a get request to this route, they should be getting all the posts, right? But your user base is so big that sometimes it might lag for this request. First thing. Second thing, there is one a particular request which does not require much of let's say much of scalability, right? So I'm just taking this for examples. I'm not talking about real cases, but let's assume that slash get slash likes does not require 16 GB RAM for a computer. For your backend, let's assume you have a backend, you have your backend hosted on a server which has 16 GB RAM, and this route does not require that much of memory, but this route requires more of the memory. This route only requires 4 GB of the RAM, and this route requires 16 GB of the RAM. So I'm giving all these examples. So basically my point is, there might be a case when you need to scale one API request more than the other, alright? But since your whole backend is hosted on a computer, how you do it? That's the first issue, right? Another issue is, let's assume that you have a computer where you had Python 3.10. I don't know what's the current version of Python, but let's assume that you have Python 3.10 installed there, and tomorrow you say to your manager that I have my application ready and let's deploy it. And he gives this the, he gives your code to another team, but they have Python 4.0 installed in their computer. So basically I'm giving just examples. I know that Python 4.0 might not be an actual version. So let's assume, we are here for assumptions, so let's assume that he has Python 4.0 installed on his computer, right? Then your code might not work on his computer because some of the modules might have been upgraded. And that's the case when every developer's favorite line comes into play, that it works on my computer. So that's the most trending, that's the most popular ways to make you understand about Docker. But let me give you another simpler example of Docker and Docker firstly. Then we will talk about Kubernetes. So we talked how you might have different version, and your client might have different version. And this is just for one case. You can say for this case, just pip upgrade pip, and he will have this. He will have the same version, but that's not possible because he has already made the whole application with that version. He can't change all these mini dependencies in his system. And we are talking about millions of not millions, but like thousands of modules for big software, right? Might be millions sometimes, I don't know, but yeah, in a good software, thousand of dependency might be there, and he might not have every dependency aligned with these dependencies. Not every dependency need to be same, but most of the dependencies needs to be same for this software to run on this software. So that was a big problem, how to solve this issue, and that's the solution Docker gave us. So Docker basically told that I will do one thing, that I will install a container in your computer, right? So this same computer now has one Docker container inside his computer of a Python image. So basically there is concept of images and containers. I won't go into deep. I want you to understand the need of Docker and Kubernetes. So I won't go into much of details. But let's assume that he has one container. So image is basically a replica. I won't say replica, but like has some characteristics or of a different image. Like Node.js might have their image as well. So in Node.js image they have Node.js installed. So it's basically a virtual machine kind of thing, but not exactly, right? So let's come to the point again. So basically this computer now has one Docker container inside his computer of a Python image, right? Now this Python image has some particular version. Let's assume 4.0. And now this computer, everything he do will be stored in this container. For example, he installs a pillow module, pillow package with 3.10, and he installs Django framework with 3.10, and he installs Kinter package with 3.2.9, let's say something, right? All these are assumptions. I don't know about actual versions, but yeah. The main point is he will have all these versions stored in this container, and not just versions, every dependency, like database dependency, etc. All these things will be stored in this container. And from now, after using Docker, this developer won't give his code base to the manager, but he will give this container to this manager. And now when this manager needs to run his code, he will directly run this machine, run this container, and can easily access his software. And this same thing can be processed on cloud. So this same thing can be processed on cloud, because basically clouds are just computers, right? But on cloud. So this thing, same thing, can be processed on cloud, and the software will run again. So in many of the cases, there was a big problem when something used to run on your computer, but it won't run on cloud because of some dependency issue, etc. But after Docker, it's so easy to containerize your application and solve the issue of all these big phrases like it works on my computer, I don't know why it's not working on your computer, right? So that's the thing Docker solved. And okay, so I hope you understand about Docker. Now now let's understand role of Docker in microservices. So let's come to the main point of our video: microservices, Docker and Kubernetes. So in microservices, let's assume that you have, I told you about two routes, slash get slash post. Here is the where are my routes. Yeah, so I told you about these routes, slash get slash post, right? And I told you how slash get slash post might require more memory and slash get slash likes might not. So in that case, Docker works magic, because now you can have your slash get slash post on one container, and slash get slash likes on a different container. Now this container will be hosted on a cloud where 16 GB of memory is allocated. I'm giving all the assumptions, just don't go into actual calculations. So yeah, let's assume this container is hosted on 16 GB of computer in cloud. But since I'm not very rich and it's not needed as well, so why waste money? So I told you that this route might require only 4 GB of memory. So let's assume it only requires 4 GB of the memory. So let's host this route on a cloud platform of a computer. So let's host this route on a cloud with 4 GB of memory allocated. Understood? So So now we have divided two of our routes differently in two containers in the cloud hosted with different specifications. So this helps us break down our software into multiple services. That's what we call microservices. So both of these routes were on a same backend before, but now it's on different Docker containers in a different specification in cloud. So now if in future slash get slash likes need 18 GB of memory, I can easily redeploy it, because if I had both of these things in same server, I might have to redeploy the same route again, even there is no change in it, because since it's in the same server, I might need to redeploy all the things, right? But since they both are on different machines, even if in redeployment, this route won't take much of your headache, won't make you sweat more, right? So this way, now we have a scalable backend divided into multiple services. That's a microservices, right? So I hope you understand about Docker now, and I hope you understand about Kubernetes as well. I know that I haven't talked about Kubernetes, but this whole process of scaling your microservice is managed by Kubernetes. And let me find the logo of Kubernetes here. Here it is. So Kubernetes is used to help you manage scalability of your microservice in cloud. So now we have understood why Docker is needed and why Kubernetes is needed, and what is Docker and Kubernetes as well. And that's all from the video. I hope you learned a lot, and I will try to bring more knowledgeable stuff in the future. Happy hacking.